Okay, so this question is about calculating the power output of a car engine. Here's some data about a car that travels along a level road at a speed of 25 meters per second. Now, this is important that the speed is 25 meters per second. It's constant. So therefore, the force, all the forces are actually being balanced. So the force resultant is actually zero. So you'll obviously have all your frictional forces, and the energy that is being produced by the engine is all to overcome the frictional forces and to keep the car moving along at 25 meters per second in a certain direction. We've got our fuel consumption as 0.2 liters per kilometer, and we've got the value of the fuel, the energy per liter is 5 times 10 to the 6 joules per liter. So every liter of fuel is going to supply 5 million joules of energy. And we've got the engine efficiency is 50%. That means that 50% of that will actually be converted to useful energy. Alright, so the rate at which the engine consumes fuel. Now, we are going at 25 meters per second, and the fuel consumption is 0.2 liters per kilometer. So if I have a look at that, I'm going at 25 meters per second. Therefore, to go 1 kilometer, which is 1,000 meters, I divide that by 25, and that is going to be 40 seconds. So every 40 seconds I travel 1 kilometer and therefore use 0.2 liters. So we are basically we're going to have 0.2 liters divided by 40 seconds is going to be the rate at which the engine consumes fuel. So it's 0.2 0.2 divided by 40 gives me 0.05 liters per second. I hope you follow that. We saw how long it takes to travel 1,000 meters. It travels in 40 seconds. Therefore, we use 0.2 liters every 40 seconds because it's 0.2 liters per kilometer. Divided by my 40 seconds, and I got my energy, my fuel usage per second. Alright, so the rate at which the fuel supplies energy, we therefore from this, so this is for 1, for 2, we've got it supplying that amount per second, so the rate at which it supplies energy, the rate of energy, we know that every liter is giving us 5.0 times 10 to the 6 joules. So we're going to get 0.05 times 5 times 10 to the 6. That will be the joules that it will produce per second. So it's joules per second. So we work it out times 5 exponent 6, and I'm going to get 25,000 joules per second. And that basically, that we can write as watts. That's the unit of watt. Alright, so we got the fuel, the rate at which, so the power output. Now we know that the engine efficiency is 50%. So this is the amount of energy per second that has been put in, the 25,000 joules per second. So the power output would be 50% of that. So it would be 0.5 times your 25,000, 0.5 times that amount, which is obviously going to be 12,500 watts would give you the answer for question 3. The power used to overcome the frictional forces acting on the car. So this would basically be this value over here, because since the car is going at a constant velocity of 25 meters per second, it's not accelerating at all. It's just constantly just going at a constant speed. So all of this energy would be used for that. So you would get 12,500 joules. So the average frictional force acting on the car, sorry, this is joules per second. We know that the car is going 25 meters per second. So 25 meters per second. So every second it's going 25 meters. So your work is equal to force times your distance. So that is going to be, the work is your 12,500. Your S is 25 meters per second. So the force would equal the 12,500 divided by the 25 meters. So we divide by 25, and we see that we get you're getting a frictional force of 500 newtons. That's acting on it. This question over here, I'm not too sure if they got the question right. This is the power supplied by the engine is not all used to overcome friction. You know, I mean, obviously the car is most of this would be to overcome friction, not overcome all air friction. I mean, there's all sorts of friction within the car. There's the wheels, to turn the wheels, to turn the different parts within the car. There's frictional force, there's air friction, and so forth. I'm not too sure what they're actually asking of in this question. I would have thought better to have said not all the power supplied by the fuel to overcome friction, because then you obviously get a huge heat loss within the engine. This one over here is important. The fuel consumption increases as the speed of the car increases. As the speed of the car increases, the air friction increases as it goes faster, because it's moving through the air faster. So the air exerts a higher friction on the car, and therefore a greater force is required. And therefore the greater force times your work that needs to be done, the energy per second needs to be increased. So because your air friction increases, you are going to needs more energy to be supplied. Okay, thank you very much.